Hello everyone, I am Muhammad Shah Alam Hussain, LSMC section, and I hope everyone is doing good. My seminar topic is MR fluid, Magnetorheological fluid, and I am doing this under the guidance of Shekhar K, Assistant Professor, BATM, Ballari. Basically, this MR fluid is a smart fluid. So, what do you mean by smart fluids? A smart fluid is a fluid whose properties can be changed under the application of electric or magnetic field. A magnetohelical fluid is a type of smart fluid composed of micromagnetic particles with the base fluid, usually a type of oil. Here, when subjected to the magnetic field, this MR fluid increases its viscosity and thus becomes a viscoelastic solid. And it's a non-Newtonian fluid. It doesn't follow Newton's law of viscosity. That is, constant viscosity is independent of the stress. Functions of the MR fluid. So as we know that these MR fluids change their properties when we apply a magnetic field to them. When the magnet is placed, the MR fluid transforms from thick liquid to the solid, and when the magnet is removed, it comes back to its original shape, that is thick liquid. Working. As figure A shows the random distribution of magnetic particles in the magnetohelical fluid, but in the absence of a magnetic field. As shown in the figure B, when the magnetic field is applied, this magnetohelical fluid changes their properties, transforms from thick liquid to the solid along the line of a magnetic flux. Due to this magnetic flux, viscosity of MR fluid gets increases and helps to reduce the shocks. And when the magnetic field disappears, the MR fluid regains its initial properties and comes back to its original shape. Modes of operation. There are three modes of operations for this magnetohelical fluid. They are flow mode, shear mode, squeeze mode. Flow mode. This flow mode is also known as valve mode. In this mode, the plates, upper and lower plate, both the plates are stationary, and this MR fluid flows between these stationary plates, and the magnetic field is perpendicular to the fluid flow. Applications such as dampers and shock absorbers. Shear mode. In this mode, one plate is fixed, whereas the other plate is in motion. And even in this mode also, magnetic field is perpendicular to the fluid flow. And this shear mode is usually used to control the rotational motion. Applications such as clutches and brakes. Squeeze mode. In this mode, one plate is moving relative to other, but perpendicular to its plane. And even in this mode, the magnetic field is perpendicular to the fluid flow. And this mode is used in controlling small millimeter order movement but involving high force. Applications. In mechanical engineering applications like magnetohelical dampers, that is MR dampers, and these dampers are used in heavy industry with applications such as heavy motor damping and cab damping in construction vehicles. Optics. These MR fluids are used in optics as a optical polishing agent and has also proven highly precise, and it was used in the construction of Hubble space. Automotive engineering, like in engine mountings, to connect the engine firmly to the frame so as to isolate the vibrations transmitted from the engine to the frame. Military and defense. Here the MR fluid focuses on the protection of soldiers from the recoil injuries during the rifle shooting. Here it can be used as a damper to reduce the recoil force from the gun. Household applications. They are used in the washing machines to reduce the vibration during the spin. Advantages. Easy to control. These magnetohelical fluids are easy to control and it is a high quality fluid and even it has a high magnitude of yield stress when compared to the ER fluids, electrorheological fluids, and the response is also faster. And these magnetohelical fluids requires less power consumption. Drawbacks. High density. Due to the presence of iron makes these magnetohelical fluids heavier, more expensive. Since the MR fluids, although being very much exciting, it is used in limited cases because of its high cost. Setting of ferroparticles. Metal particles tend to set after long-term use. The last one, fluids are subjected to thickening of prolonged use, due to which replacing is required. So, conclusion. The MR fluid, whose viscosity is a function of applied magnetic field, will replace the conventional based mechanisms and it also improves in cost reduction and functionality of the system. This MR fluid also has a wide range of application. There is a lot of future scope for this technology. If these MR fluids are used in our day-to-day life, it will provide a greater solution to many maintenance problems because these fluids are resistant to water and dust contamination. And even the temperature variation doesn't affect the fluid's performance up to certain limits. So these are the some references which have referred from my topic. So thank you everyone for your precious time.